Good day. Today we will be looking at tangents to curves in calculus, and I trust that the preceding examples were clear enough for you to understand what a tangent is. Just in case someone did not see the preceding videos, just going to briefly explain what a tangent is. I have a line, I have a circle. In this instance, the line does not touch the circle, so it's merely a line and a circle. Here I've got a circle with a line running through the circle, touching the circle at 2 points. We call this line a secant. Then we have a circle and a line, and this line touches the circle at 1 point only. That is called a tangent. If I look at the parabola, where the line touches the circle at 1 point only, that point of contact, that line is a tangent. Another explanation that was given was that if point B moves towards point A, the limit of B moving towards A becomes a tangent to the curve. I just want to show the tangent there. So the line touches the circle only at 1 point, and that we call then a tangent. Okay? So the limit of B moving towards A becomes a tangent. Likewise, the limit of A moving towards B also becomes a tangent at that point. Trust you can all see that. In this topic specifically, we will look at how to calculate the equation of a function, of a tangent to a function. So please take note, this question can be asked in different ways. Most commonly they ask you to calculate the equation of the function at a point, but they can also ask you to calculate the point of contact if the gradient of the tangent is given. So first of all, we need to understand something very specific. When I work with functions, any function, the derivative of the function is equal to the gradient of a tangent to the curve at a specific point. So let's look at the function that is given. G of x is equal to a third x to the power of 3 minus 2x. So the derivative of this function, g dash x, is equal to the exponent 3 multiplied with the coefficient a third, gives me 3/3, and then 3 minus 1 is 2, and 1 multiplied by 2 gives me negative 2. So the derivative can be seen as x squared minus 2. Now they've given me the gradient, which is 7. I substitute the gradient in the derivative's place, and I say x squared minus 2 is equal to the tangent. Now I can solve for x. There's two different ways I can solve it, but I'm going to focus on this one, where I isolate x. X squared is equal to 9. That means x can be 3 or minus 3. Remember, positive or negative. If I had gone the route of x squared minus 9, the difference of squares, I would have had x plus 3, x minus 3. Answer would be x is equal to 3 or x is equal to negative 3. Right? Now we have the x value. We still need to find the corresponding y value. So we need to substitute the value of x into the original function to calculate the corresponding y value, or values in this case. Right? So I firstly substitute the 3 into the original function, and then I substitute the minus 3 into the original function, and I calculate the values. So I've got 27 multiplied by a third is 9, minus 6 is 3. 27 multiplied by a third is minus 9. And minus times a minus is a plus 6. Difference between 6 and 9 is 3. And I keep the sign of the biggest number. So my points of contact, where that tangent will be at 3 and 3, or at negative 3 and negative 3. Let us quickly see what this means. There's one point of contact at negative 3 and negative 3, and there's one point of contact at positive 3 and positive 3. Let's look at this line. We can see this line is parallel to that line, and the points of contact is a tangent to the graph at those 2 points, and that's why we had 2 solutions. I trust that explained this particular sum in particular. They wanted to know the points of contact where there will be a tangent to this graphs.